Hello, welcome to Unit 6, Video 1. Today we're going to go ahead and look at the Pythagorean Theorem. Your learning target is that you can apply the Pythagorean Theorem. The Pythagorean Theorem shows up a lot in the ACT, so you want to make sure that you're completely understanding it and you understand when you can use it. So we're going to look at that today. Years ago, a man named Pythagoras found an amazing fact out about triangles. He noticed that if the triangle had a right angle, which is 90 degrees, so here's my triangle, it has a 90-degree angle, and you make a square on each of the three sides, okay, so you can see the three squares that he made. The biggest square has the exact same area as the two other squares put together. So if I'm talking about the area of a square, this one is a square, so it's b by b, so b times b is b squared. So my area is b squared. This one would be a times a, which is a squared. And this one would be c times c, so resulting in c squared. He noticed that when you do this all the time, that when you add these two together, they equal the area of the bigger one, which gave us the Pythagorean theorem of a squared plus b squared equals c squared. Biggest thing to remember is that c has to be the hypotenuse, or the longest side, because that's what will give me the biggest square. So that's probably the hardest piece to remember when you're working with the Pythagorean theorem. So example 1, okay, it says find the missing side of the triangle using Pythagorean theorem, and then make sure it says leave answers in simplified radical form. So 2 squared is 6, not 4.9. So looking at number 1, we are trying to find the longest side, so that is my c. So I would have, if I have a squared plus b squared equals c squared, my c squared is my x. So it doesn't matter who a and b are, just that we have 6 squared plus 15 squared equals x squared. 6 squared is 36, 15 squared is 225. And when I add 36 plus 225, I get 261 is equal to x squared. And now in order to solve for x, I would take the square root. Biggest thing to remember is when you take a square root, there's two answers, positive and negative. However, whenever you're using the Pythagorean theorem, you're never going to want a negative side length. So x will just be equal to the positive square root of 261. From here, we need to go ahead and see if I can break this down into any perfect squares. So if I have 261, is there any perfect squares? It is 9 times 29 is 261, so it's really the square root of 9 times 29. And I know the square root of 9 is 3, so I write it as 3 square root of 29. That would be my answer for number 1. Going ahead and looking at example 2, okay, if I look at this one once again, I'm going to go ahead and solve for the hypotenuse. So I would have 17 squared plus 7 squared is equal to x squared. 17 squared is 289 plus 7 squared is 49 equals x squared. Adding these two together, I get 338 is equal to x squared. Once again, take the square root. So I have the square root of 338, so I probably want to figure out what are my perfect squares in 338. Is there any? So I play around. I know it's divisible by 2, so if I just try 2, I get 2 and 169, and the square root of 169 is actually 13, so that works out perfectly. So x is equal to the square root of 169 times 2. And like I said, the square root of 169 is 13, so it's 13 square root of 2. That's my answer for number 2. Okay, going ahead and looking at number 3. Just going to move it over here real quick. Number 3. Okay, looking at this one, my hypotenuse. This time they actually gave me my hypotenuse. Always across from my right angle, always that longest side. So this is my c. So in this case, I would actually have x squared plus 9 squared equals 11 squared. So I have x squared plus 81 is equal to 121. Now this time I don't have anything to add together on the left-hand side, so I would subtract 81 from both sides to solve for our x. 121 minus 81 is 40. Okay, then I take the square root. And now I'm asking myself 40. What does 40 break into? Well, I know it's 4 times 10. So x is equal to the square root of 4 times 10. The square root of 4 is, 2. So it's 2 square root of 10. So my final answer for 3 is 2 square root of 10. Okay. So those are just some basic apply the Pythagorean theorem. Now let's go ahead and look at a word problem. Damon is locked out of his house with the only window open on the second floor, 12 feet above the ground. So I would look 12 feet above the ground. It's labeled. He needs to borrow a ladder from his neighbor. He must place the ladder 5 feet from the house to avoid some shrubs. So that's labeled 5 feet. What is the length of the ladder Damon needs? So we're trying to figure out x right here, the length of the ladder. Okay, so maybe it's better if I redraw this triangle over here. So we have to be, it's not very accurate drawing. Let's go ahead. That. 5 feet away, 12 feet high, and we want to know how long the ladder needs to be. This is my right angle. So across from my right angle is my hypotenuse, or your C. So I would have 5 squared plus 12 squared is equal to x squared. 5 squared is 25. 12 squared is 144 equals x squared. If I add them together, I get 169 is equal to x squared. Take the square root. X is equal to the square root of 169, which is 13. So he needs a 13-foot ladder. 13-foot ladder. Okay, that is example 4. Let's go ahead and talk about some common Pythagorean triples. If you noticed in example 4, we got nice whole numbers. We had 5, 12, and 13. That's an example of a Pythagorean triple. Okay. Pythagorean triples work out nice because if I plug them into the Pythagorean theorem, like these here, okay, so I'd have 3 squared plus 4 squared equals 5 squared. They give me whole numbers out. So I would have 9 plus 16. Does that equal 25? Yes, it does. So if they're nice whole numbers for all of these, then they're a Pythagorean triple. You don't need to memorize these, but they are sometimes helpful. 'Cause sometimes if I say one side's 3 and 4, you could automatically say, well, the third side's 5. You don't have to do the Pythagorean triple. Okay. So these are the common ones, 3, 4, 5. The nice thing is I could take them and multiply them by any number, and that would be another Pythagorean triple. So this one, if I multiply them by 2, another option would be 6, 8, and 10. Multiply them all by 10, I would have 30, 40, 50. So there's multiple common Pythagorean triples. So we could essentially just write it as it's 3 times any number, 4 times any number, and 5 times any number. Another Pythagorean triple is the 5, 12, 13 triangles. Same thing here, you can multiply them by anything. So if I take it by 2, I would have 10, 24, 26. Multiply those by 10. You'd have 50, 120, 130. And if you wanted to find more Pythagorean triples, you just take each one of them and multiply them by the same number. And lastly, there's the 7, 24, 25 Pythagorean triples, which I could do the same thing. Times it by 2, so 48, 50, that's another example. Times them by 10, I would have 70, 240, 250. And if I wanted to find more, I would just take them by any number I wanted. Just make sure you multiply them all by the same number. So they're nice because they give you whole integer values and no, square root of anything. Okay, so those are Pythagorean triples. Let's go ahead and try another one. So 5 says find the value of x. I notice it's a right triangle. I notice I'm missing one side. So I'm going to go ahead and give the Pythagorean theorem a try. My hypotenuse is across from the 90, so I have my C value. So in this case, it's 10 squared plus x squared equals 14 squared. So I have 100 plus x squared. 14 squared is 196. So x squared is equal to subtract 100, 96. take the square root, and x is equal to the square root of 96. But we always have to try and break it down. 96. Any perfect squares in there? It's 16 times 6, and some of those will just come with plugging in your calculator and trying to find it. So 16 times 6, the square root of 16 is 4. There is no more perfect squares than 6, so it's 4 square root of 6. That would be my answer for number 5. Number 6, I'm going to go ahead and find the value of this one. Let's go ahead and move this one to another page so we don't run out of room. This one has more than one x going on it. So once again, I see it's a right triangle, and I have my 3 sides. So I'm going to go ahead and try Pythagorean Theorem. And there will be a problem like this on your upcoming quiz. So I set it up. This is my hypotenuse, so it has to be c. So I'm going to have x squared plus square root of 2 squared equals x plus 1 squared. It says find the value of x. We need to solve this. I know that x squared is just going to stay x squared. My square root and my square cancel, so plus 2 equals, now here's the tricky part. This is really x plus 1 times x plus 1. So you need to FOIL that. I'm just going to rewrite my left-hand side. And if I FOIL, I have x squared plus x plus 1. So x squared plus 2 equals x squared plus 2x plus 1. And one thing I noticed is they both have an x squared. So if I subtract x squared from each side, those cancel. And I'm left with 2 is equal to 2x plus 1, which is a nice problem we know how to solve. I would subtract 1. 2 minus 1 is 1, so it equals 2x. Divide both sides by 2. So x is equal to 1/2. There it is, solved. Okay. So if you have any questions on number 6, please let me know, because there will be a problem like this on your upcoming quiz. Then, number 7, we want to find the value of x. I'm trying to trick you by putting it in a rectangle here. But I see my right triangle. My hypotenuse is across from my right angles, and it's x. So this one is 9 squared plus 12 squared equals x squared. This is 81 plus 144 equals x squared. Add them together. 225 equals x squared. Take a square root. So I would have 15 is equal to x. So this is an example of a Pythagorean triple, because I would have 9, 12, 15, and they were all whole numbers, so just something to take notice. So my answer for that one is 15. Okay, that will be the end of our notes for the Pythagorean theorem. If you have any questions, please let me know. Otherwise, have a great day, and I'll see you later.